Welcome to EPG Pathshala. I am Pirzada Rauf and I teach at Jindal Global University. Today, we'll be talking about theories of resource geography. In theories of resource geography, we have some keywords, and those keywords are nomothetic approach, objective supply, hypotheses, knowledgeable supply, and mineral resources, as well as economics. In introduction, I will talk about the types of theory, what is a theory, and in a theory we have a list of related laws which together explain a broader concept. A law is a statement which explains how a particular part of the universe works. For example, every action has an equal and opposite reaction is one of the Newton's laws of motion. Newton's laws are part of the theory of classical mechanics. Sometimes, such as in the theory of evolution, we have certain laws contained in the theory as facts. Other times, such as in the theory of creation, the laws within which are with errors, untruths, wrong answers. Whether sometimes something is a theory or a law has no bearing on whether or not it is a fact. If we are not yet sure whether a law or a fact or an error, then that law is a hypothetical law. A theory composed entirely of hypothetical laws is a hypothetical theory. Anything that is hypothetical is also a hypothesis. Much like how your douchebag boss is simultaneously a human being and a douchebag. Every science has a goal, that is, to understand and explain the real world phenomena. Developmental theories are the vital for scientific understanding of processes that control the human special relation with humans and also with the nature. Few would deny the fact the last few decades have been one of the greatest periods of intellectual changes in the trends of geographic development. Most of these changes, the questioning of the past approaches, looking at old problems and with the new eyes, with the new lenses, with the new knowledge, we have been able to develop a methodological nature which is evolving and involving virtually at every instance the substitution of quantitative approaches to problems formerly treated in descriptive ways. Today, an apparently new perspective has been opened under the impact of so-called quantitative revolution. Statistical methods have been introduced to attain a desired level of objectivity, and the search for models and theories have proceeded at pace. The works of Hodgson may be considered at last in the chain of traditional writers in geography. The traditional concept developed by Hodgson came under attack in 1950s. This was mainly due to the growing trend of scientific analysis in social science. A growing number of geographers became aware of the mathematics and statistics that could be applied to geographical problems and models. These provide a precise tool or tools to test the theories, which were traditional theories, and to analyze the data and the results. The process of intellectual change that led geographers to concentrate less and less on describing the differences between particular areas or places or more on the study of uniformities and the production of theories about the spacing of phenomena on the Earth's surface. Such an emphasis on nomothetic approach is in the right direction. Besides, during the last few decades, we have seen the focus has also changed to make the concept of systems of much greater significance, like world systems theory. And along with that, we have models and theories. The search for generalizations based on whole rather than individual parts is therefore a complementary as dealt with by Ackerman. A theory is also defined as a system of ideas explaining something or a system of ideas based on general principles, independent of facts or phenomena to be explained, or a scientific approach or a statement or a group of scientific statements. In order to understand the meaning of theory, the difference between a simple and a scientific statement needs to be made clear. Now consider these two statements as under. For example, like if we say that Delhi lies across the Yamuna River, one finds the big cities generally located across rivers in the world of the above two. The former is a simple statement, whereas the latter may be called a scientific statement, because the scientific statements are based on generalizations derived from a number of simple statements that are facts. But after searching out some relationship or order, we state it or express it in the form of scientific statements. The generalization we make, or the law and the theory which form the order of scientific research. Thus, the theories are the highest order of scientific statements or the universal statements. They state some rule or some action, behavior or process or for development. Here, if we have to understand the structure of a formal theory, we will understand it through the scientific theory, which includes terms, calculus and statements. These forms the part of the scientific approach to the study of a phenomenon. The various words that constitute the specific vocabulary of a theory with its terms, and these terms are building blocks of scientific understanding. The terms and which are derived are most essential for scientific understanding. The axioms are the primitive terms that are based on original and non-derived phenomenon. For example, a point or a line in geometry, and a river, a plain, a settlement, a market, a desert, road, etc. in geography. The derived terms, on the other hand, need further definition, as they may have several connotations. They are formed from the primitive terms as described by various geographers. So, first let's deal with neoclassical theory. Ever since the growth of capitalist economy in a slow manner, the issue of natural resource has become of vital concern for the bourgeoisie. This need perpetuated in the academic circle and finally became the part of state's agenda. Between 1890 and 1920, resource conservation on the public domain became a national issue in the United States. President Roosevelt defined conservation as the application of common sense to common problems for the common good. This and the other amorphous views of resource conservation would attract interest of economists looking for better definitions to the issues and inform public policy. The primary problem of conservation, writes L.C. Gary for the Quarterly Journal of Economics in 1913. He says it is the determination of a proper rate of discount on the future with respect to the utilization of our natural resources. And about the discount rate, Gary said, the crutch of common sense, and called for the economists to develop the theoretical basis upon which the solution of these ultimate problems of conservation must depend. Despite the open questions, Gary was convinced about present period overproduction, an example of what economists would later call the market failure. He championed the creation of high values through the socialization of these resources which are not used, and of those which, on account of their relative abundance, are being used in an exploitative way. Gary's article, the beginning of 20th century conservation and conservation economics, contained three important and enduring perceptions or percepts, which is fixed objective supply. Minerals afford a tolerably clear-cut type of resources which are absolutely limited in supply and non-restorable. It is necessary to make a definite choice between a present and the future. Normally, when one is once used, the supply is exhausted practically for all time. This is absolutely true in the case of coal, petroleum, and natural gas. Knowledgeable or knowable supply, the nation has reached the point where it is possible to make a rough inventory of its mineral resources. Society is confronted by the same choice that accumulation imposes on the individual. A choice between present satisfaction and future satisfaction. The neoclassical economics takes Gary's cue and derives an objectivist theory of mineral resources that maintains or remains in the mainstream today, which is Harold Hotling's idea. In 1931 essay in the Journal of Political Economy, Hotling applied differential calculus to derive the optimal allocation of a fixed resource over time. He began by nothing that standard economic analysis usually used to do. It was plainly inadequate for the industry which the indefinite maintenance of a steady rate of production is a physical impossibility and which is therefore bound to decline. A fixed, objective, knowable supply was the starting point for Hotling, as it was for Joas and Gary. Hotling showed that if the total resource base was known and fixed and homogeneous, if the capital investment was fixed, if the deposits were mined in order to objectively know least cost, if the most efficient extraction methods were used, if resource prices were known in each time period, or just if profit maximization automations had perfect knowledge, the resource would be produced and sold at a net price, marginal revenue minus marginal cost, that rose at the rate of interest over time. This price minimum, the depletion value of the resource rent, also called Hotling's rent, Hotling's rule and user cost, was revenue stream that only a fixed and exhaustible resource could command. Ludwig, on other side, his idea explained human action as the important aspect of resource development. Ludwig briefly addressed the theory and political economy of mineral resources. Ludwig starts from the fixity feature of the minerals that cannot be systematically produced in human time frames but only found, as it were. From the basis, Ludwig goes on to conclude that exhaustibility is casual for human action in the local sense. Every single mine or oil source is exhaustible. Many of them are already exhausted. But holistic notions of aggregate supply and future availability are of academic concern and do not matter to the present day conduct of mineral entrepreneurship. Acting man faces a variety of mineral resource opportunities. That means the choices are made at any one time between developing certain deposits and no other submarginal deposits. Because of one and two. One is the deposits of mineral substances and their exploitation are not characterized by the features which would give a particular mark to human action dealing with them. Thus, Ludwig rejects the notion of a special economic rent possessed by resources that he defines as fixed in aggregate. The geographical dispersion of natural resources makes the problems of transportation a particular factor of production costs and makes institutional factors, which are important. And his theory of minerals is thus opposed to that of Hotling. There is no unique theory of exhaustible resources or of mineral resource economics. The history of minerals to Ludwig points towards enough prospective abundance so that the macroeconomics does not impinge on microeconomics of human action. The same marginal economic analysis applied without the pronounced reservation demand on the part of seller to differentiate minerals from other goods and services. So, also talking about Hayek. In the pure theory of capital, Hayek contrasted wasting natural resources in 1941 with the produced means of production. Both were considered capital, but only the later were considered capital goods. A new and a useful output created by the land labor capital triad, but forever is outside of economic time. This triad, which ranges from the moment to years, decades and even centuries, when talking about a particular mineral form, to his credit, Hayek understood that a mineral resource firm had to continually find more exhaustible supply to remain a going concern. But he was in the Hotling's world when he concluded, if income is to be maintained permanently at a higher level, which the wasting natural resources make possible, these resources will, as they exhausted, have to be replaced by produced means of production. Here we understand how a person like Hayek, a libertarian, thought about the resources. So we have another theory, that is the functional theory of resources, and is a dynamic concept of understanding the resources. There is a great controversy about the meaning and the definition of resources. The exponent of the old and static school hold that natural phenomena are all resources. They are already in the realm of nature and are fixed or static. Resources are not made or created. Man, by his intelligence and skill, has simply developed some of the natural resources, making them suitable for human use, and the rest of the natural resources are still to be underdeveloped or still left underdeveloped. Resources are not made or created. Man, by his intelligence and skill, has simply developed some of those natural resources, making them suitable for human use, and rest of the natural resources are still left underdeveloped. To this old school of thinking, resource means nature. Natural things, good or bad, effective or ineffective, are all resources. To them, the hydroelectric potential of the Congo River and the coniferous forest belt of the higher slopes of Himalayas are all resources, even though there is little chance of these being used under the present socio-economic condition of the countries. But according to these people, all these natural resources are resource, whether it is India or Congo. This view about the resources without any reference to their functional aspects is not acceptable to the modern thinkers. Here, the most important understanding of this view by Professor Zimmerman and other supporters of modern school hold that resources bring human welfare. They talk about natural phenomena that are not all beneficial to man. In nature, there are floods, earthquakes, storms, poisons, etc., which hinder human progress and welfare. These are not to be treated as resources. To them, resources are not confined to that of what the natural resources, but it also includes the human aspect of resources. Humans, with their skill, their organization, their mental abilities, their intelligence forms resources for the society at large. Believe in functional aspects of resources, that is, the significance of a stuff is to be realized only in context of a function which it performs for the humans. That the resources are not static but are dynamic. So Zimmerman in 1993 identified resource theory as a stepchild of economic analysis. If resources were recognized at all, they were absorbed into the market processes, acknowledged only so far as they were reduced to working tools of the entrepreneur. Land, labor, and capital are recognized, though, through their effects on cost and price, supply, as well as on demand. What was needed was a theory of human as well as of cultural resources, for the nature and the culture to have become so intertwined that a little can be gained from an attempt to isolate the natural resources. Cultural and natural resources are inseparable and can only be considered together, and he describes here his contribution as to the functional theory of resources, since the concept of resources is purely functional, inseparable from human wants and human capabilities. Resources to Zimmerman were conditional things. Conditional in the sense that they were created and destroyed by changes in the consumer demand. See, this is an important concept here. He talks about resources are dynamic not only in response to increased knowledge, improved arts, expanding science. He wrote, and I will quote, but also in the response to change individual wants and social objectives, unquote. This was not a priori theory but empirical fact. One has but to recall some of the most precious resources of our age, like electricity, oil, nuclear energy, to see who is right, the exponent of the static school who insists on resources are, or the defender of the dynamic school, the functional operational school which insists that resources become. Resources could be created, but they could also be immobilized by the facts of man. In his words, the resources at the disposal of man evolve out of working combination of natural, human, and cultural aspects, a combination which expands with every advance of human knowledge and wisdom, and has every relapse into the barbarism of war and civil strife. Zimmerman elaborated, a functional interpretation of resources, like makes any static interpretation of the region's resource appear futile. For resources, the change not only with every change of social objectives, respond to every revision of the standard of living, change with each new alignment of classes and individuals, but also with every change in the state of arts, institutional as well as technological. And again, laws, political attitudes, type of government, the government policies, along with basic geological and geographical facts become the strategic factors in determining which oil fields will be converted by foreign capital from useless neutral stuff into the most coveted resource of the modern times. Now, dealing with the summary, we have covered points like every science has a goal, that is, to understand and to explain the real world phenomenon. Although geography is short on theories and long on facts, yet development of theory seems to be vital both to satisfactory explanations and to the identification of geography as an independent field of study. Ever since the growth of capitalist economy in the slow manner, the issue of natural resource became a vital concern for the resource geographers as well as the bourgeoisie. For them, this need perpetuated in the academic circle and finally became the part of state's agenda. The fixity and the depletion between 1890s and 1920s, that is the height of industrialization in Britain, resource conservation on the public domain became a natural issue in the United States. President Roosevelt defined conservation as the application of common sense to the common problems for the common good, as discussed above. Man, by his intelligence and skill, has simply developed some of those natural resources by making them suitable for the human use, and for the rest of the natural resources are still left underdeveloped. Thank you.